This is a video on exponential growth problems. The question states, the population of the quagga mussel grows proportionally to the number present. 20 quagga mussels were introduced into the lake 2 years ago. Last year, there were 160 mussels in the lake. How many will there be next year? So we start out with the exponential growth model, and that says when the population grows proportionally to the number present, well, growth is the derivative. If y is a population, then dy over dt, and proportionally means equals k times, and then the number present is y. So we get dy dt equals k times y. Now let's solve that differential equation. I'm going to divide by y and multiply by dt, and I get dy over y equals k dt. Now integrate both sides, and the integral of dy over y is the natural log of y. We don't need the absolute values because y is a population, it can't be negative. And the integral of k is kt plus some constant, I'll call it c1. So now let's solve for y. If we exponentiate both sides with base e, we get y equals e to the kt plus c1. I can use the exponential rule that says I can break up an addition and write this as e to the kt times e to the c1. Now if c1 is a constant, e to the c1 is also a constant. I'll call that c. And there's my population growth model. Y equals ce to the kt. The next thing I'll do is use my initial conditions. 2 years ago, I'm going to call that time 0. So at time 0, we had 20 quagga mussels. And what we get is that y of 0 equals 20. Last year is 1 year after 2 years ago. So that's when t is 1. Then y should be 160 because there were 160 mussels in the lake last year. And we get y of 1 is 160. So now let's use this first initial condition. I'm going to plug in 0 for t and 20 for y, and I get 20 equals c e to the k times 0. E to the 0 is just 1, so that tells me c is 20. Plugging in c equals 20, I get y equals 20 e to the kt. Next, I'm going to use the y of 1 equals 160, and that means t is 1, y is 160. So I plug in, and I get 160 equals 20 e to the k times 1. Divide both sides by 20. 160 divided by 20 is 8, and that's e to the k. And then take a natural log of both sides, and I get k is the natural log of 8. So now I have my model with no constants. Y is equal to 20 e to the natural log of 8 times t. I want to know how many there will be next year. Well, next year corresponds to 3 years after 2 years ago. So that means t is equal to 3, and I plug in 3, and I get y of 3 is 20e to the natural log of 8 times 3. And I worked that out, and what I ended up getting was 10,240 quagga mussels in the lake next year. And I'm done with the problem.